Hello everyone, this is a video about two-dimensional arrays. Now, we have talked about one-dimensional array. It just stores a sequence of elements. The word list here on the slide should not confuse you. Arrays are different from array lists we talked about in the previous Java class. Array list is a dynamic data structure. You can add or remove elements and the whole structure is going to get bigger or shorter. Whereas array is static, so you specify its size at the time of the creation and then you cannot change it, you can just delete the whole thing. You can change the values in it, but you cannot append one more value like you would do in a list in Python or with array list in Java. Now, when you talk about two dimensions, you see a table like this, and in order to work with this table, you need to reference each cell. And that requires basically two coordinates or two indices, a row index and a column index. And notice that I will always say the row index first and the column index second. Now, which one is row and column is a matter of my choice when it comes to Java. Java does not really see it as a two-dimensional thing, nor does it need to. However, this is our decision, and in your code you should be consistent and know the order in which you are referencing the element. So if I wanted to reference element 2, 3, I would start from 0, because that's how programming languages are counting. 0, 1, 2. This is row 2, and I said that the element is 2, 3, so I have to move 3 columns now. 0, 1, 2, 3. Actually, 4 columns. And here we are in this cell. So we will need to be consistent with enumeration, and the same thing that I was talking about with one-dimensional array, which is n-1 error, so error by 1 when you are iterating through them, you need to keep track of it when iterating through two-dimensional arrays, even though now you have two indices to work with. All right, let's look for a bit how Java actually initializes the arrays. Int bracket bracket means two-dimensional array of integers. The name of the array is table, and to initialize it we use the new keyword, and then int bracket 12 50. So we are creating an array 12 by 50. So talking about rows and columns, 12 will be the number of rows, 50 will be the number of columns. And do not confuse this notation, the initialization of this array, with this notation, table 36. It is actually referencing a cell or an element in the array, rather, I would say element from now on, with index 3, row index 3, and column index 6. So if you want to reference the entire row, you are referencing just the first index. You can do that. Okay, so for example, table 5 will reference an entire row, array of integers, which has index 5. So a row index 5, so that will be the 6th row from the top. And again, 512, table 512 references the element with row index 5 and column index 12. All right, this is a cute little example that we'll be able to work through real quick. So first of all, we create a table, two-dimensional array, 5, 10. Those are the sizes, 5 rows, 10 columns. And now we have a nested loop, and you can slow down to look at it slowly. Remember, look here, your length of the table row actually depends on row. So that is a good thing to remember and include when you're working with it. So we are doing a nested loop to basically run through every element. And the order of this nested loop is such that first we generate a row number starting from 0. Then we do the inner for loop, which is running along all the columns. And row times 10 plus columns. Feel free to pause and think what it will do, but I will show you the result shortly, or you can look it up in the book. And also another nested for loop just to print the table, print the values, and notice here tab for better formatting. And the result is 0, 1, 2, 3, and so on, till 9, then 10, 11, and so on. So row times 0, for the first row is 0, because we begin indexing from 0, so that is 0 plus column number. So this is enumerating column numbers. For the second row, the first digit is the row number, and actually, you can see for every row, the first digit is the row number, row index more precisely. And the second digit is the column index. I think it's a pretty smart example. That's what this example is about. And now let's do our own little example. So, two-dimensional array. I'll call it 2D array. Okay, PSVM as usual. And I'm going to instantiate an array. Let's think through the sizes here. Rows 0, 1, 2, 3, and columns 0, 1, 2, 3, 4. And just for an example here, I put in the indexing for the corresponding cell, for the corresponding element that would be here. So row 0, column 3 references this element, and of course it's a different element from row 3, column 0. So be consistent with your indexing. Okay, so int bracket bracket, let's call it table, equals to new int, and I think I said 3 by 4, 4 by 5, 4 by 5. So count the number of columns, count the number of rows first, columns second, 4, and 5. And actually, you know what? Let's make it string. And I'd like to have a static function to print stuff, to print an array. Public static void prn for print, and I will pass our data structure to it, and maybe call it t. And here goes the for loop for int I equals 0, you know, the usual thing. I strictly less than to avoid the error by 1, prn, sorry, t dot length. So note that the outside loop is over the row numbers. And then for int j equals 0, j less than t bracket I dot length, and it does not like something, so I'm gonna, oh yes, I++ in both places, j++ here, increasing the index by 1, and here j++, sorry, I++. Alright, so we created a nested loop, and inside this nested loop, all I want to do is just to print the value. So system println. Actually, we don't want to println. We want to print t, that is the name of our data structure, string two-dimensional array, t plus, let's say, a tab symbol. So we will print it, and actually, why don't we do it right now, just to remind ourselves what are the default values. prn table. Let's run this, and in the meantime, while it runs, we will start to do the next thing. Just for fun, we are going to populate some values. So table, oh, so it printed, but it did not print what I wanted it to print. I kept printing t instead of, so it what it was doing, it was printing the array with addresses, because that's what each cell has. It has an address. So what I wanted to do here, sorry about that, I and j. Alright, so now it will do what we want it to do. Well, it printed nulls because we initialized it, but we did not populate it with any values. And that is not very informative. So I want to print it in a good way so that it actually resembles the table as I described it. So I want to see like a kind of grid pattern over here, a table actually. So first of all, to do that, I need, outside of the inner loop, I need to just have an empty printing statement. Take a moment and think what should be different about this empty printing statement. And yes, there should be ln. So print line, that will advance it to the new line. Here we go. Now we will have a grid. Here we are. So we have a grid of nulls. And how about we actually populate some values in here? So table. Which values do I want to populate? Let's look. 0, 3, that is a value over here. And 1, 3, that is a value over here. And just for an example, you can choose to populate another value. Just you need to be able to control it. So table 1, I said 0, 3, right? 0, 3 equals to hello. And again, table 1, 3 equals to world. So what I want to have and what I'm going to have over here and over here, I'm going to have hello. Here I'm going to have world. Okay. And I did not print it again. So. Here we go. Alright, so maybe I should insert some empty printing statement or some fancier printing statement so that we can see that one example finished and the other started. Okay, so let me do this and multiply it by 40. I think that was Python of me, so I want to repeat int count 40. Alright, that works. And maybe include one more, so we will have 2 lines between them. So the first one is still the nulls, all of them are nulls. Here we are. This is a table of nulls as we created it. That's the first printing statement. And then the second printing statement, for some reason I cannot really see it. Oh, oops. Where did it go? It went over here. So, my bad, ln. And I should have noticed it because actually there was one line instead of 2 lines. Okay, print the line, and we're good now. So we will be able to distinguish between them. Here we go. So this is a null as previously, and now we have hello world, and you can check that the positions are exactly the same as I prescribed over here. So row 0, column, row index 0, and column with index 3. And here is row index 1, column index 3. And the rest of them are still nulls. And that is our basic example.